Okay, so recording, we're discussing confidence interval worksheet number 1. Let's read the question. So prayer in school, a New York Times / CBS News poll asks a random sample. That's good. It's got to be random, right? We talked about that. So that's a key word. Random. Random sample of U.S. adults, the following question. Do you favor an amendment to the Constitution that would permit organized prayer in public schools? So that would allow. Would it be okay to have organized prayer in public schools? Based on this poll, it's a 95% confidence interval. Okay, that's important to know as well. For the population proportion who favors such an amendment is 0.63 to 0.69. Okay. So this is your interval also. So really what they're saying, and that's actually the first question, because we do have to interpret it. How do we interpret this, right? So you would say, for part A, we are 95% confident that the percentage of people, or percentage of US adults, let's be very specific here, favor such, so sorry, let me rephrase that. We use proper grammar. We are 95% confident that the percentage of US adults who favor such an amendment is between 63% and 69%. And let me size this up so it doesn't take up too much space, or size this a little differently. Okay, there we go. So that's how you interpret it. You're 95% confident that the percentage of US adults who favor such an amendment is between 63 and 69%. Now, they gave us a proportion, but that's the same thing as a percentage. So if the proportion is like 0.5, that'll be 50%. Proportion is 0.63 or 0.69, 63 and 69%, just so you know. So we can convert to percentages since that might be more tangible or easier for us to fathom, right? And also, this tells us that if I were to run this sample or run this survey 100 times, then 95 of my intervals will contain the exact percentage of all US adults who favor an amendment. Because of course we're doing a sample of all US adults, right? It's a random sample. But if you actually were to poll every single American adult and then get that percentage, maybe it's 64% or 62%, I don't know. But whatever that number is, when I do a 95% confidence interval, if I run the survey 100 times and then use 95% confidence interval for each of those samples, of those 100 intervals I've made, 95 of those intervals will contain the actual percentage. So that's another way of interpreting it as well, but a little easier to explain what I just did here. So, because it gives you that confidence, right? That I'm confident that, you know, if I did 100 intervals, 95 of those intervals would have the actual number of people who favor such an amendment or the percentage. Okay. Nope. And let me clear that up. Okay, let's keep moving. So what is the point estimate that was used to create the interval? What is the margin of error? So what you do for the point estimate, what that really means is the midpoint of your interval. Which is actually the mean. So for part B, you have 0.63 and 0.69 as the lowest and highest values of the interval. Divide that by 2, just that simple as 0.66. So that's your point estimate. And then for the margin of error, let me erase this other stuff. I don't need this here. Oh, I do not want to do that. What? Okay, here we go. The margin of error is simply the difference between those two divided by 2. So in this case, we'd say our confidence interval could be 0.66 plus or minus 0.03. That's another way you could express your confidence interval as well, just so you know. Instead of writing as an interval 0.63 to 0.69. Okay, and then for part C, excuse me. Based on this poll, reporter claims that more than 2/3 of US adults favor such an amendment. Use a confidence to evaluate this claim. So 2/3, hopefully you guys know, is like 0.6 repeating, or 66.7%. So what I would type is I'd say this claim seems plausible since two-thirds equals 0.666 repeating, and that number is contained in our CI, Let me move that so you guys can see a little better. There we go. Remember, I'm recording this, and I'll upload the recordings to the updates in School. And actually, I'll even put them in the week 3/4 folder as well. And I'll date them so you guys know. And I'll even tell you what I talked about. So I'll make sure it's all labeled nicely for you guys. That just always takes about a good 15-20 minutes. Just got to dedicate that time, and I should have that time this afternoon. Anyway, yeah. So 2/3 is 0.6 repeating, and that is what contained our interval. So yeah, I'd feel confident that kind of makes sense. If someone made a claim that 3/4, 75%, I'm like, I don't really know about that. That seems a little high to me. Or someone only half, I was like, that seems like an underestimate. So that's how we would interpret this stuff. Okay. Any questions so far about that question? Nope. Okay. If you have questions, please feel free to speak up, or you can put something in the chat. Now, in this case, they're asking to interpret the confidence level. Okay, so that's actually what I mentioned a few minutes ago. Not the interval, but the confidence level. So here's how we would want to say that one. You'd say that if we conducted the survey 100 times, then 95 of the, it made a confidence for each of those samples, 95 of our intervals percentage And let me resize that. There we go. So if we conducted this survey 100 times and made a CI, remember CI stands for confidence interval for each of those samples. So you have 100 intervals. 95 of those intervals would contain the true percentage of US adults who favor this amendment. I mean, let's say the true percentage is 65%, then I would expect 95 of my 100 intervals to include 65% in that interval. So that's how that works. Okay, so now let's look at the next one. More about parent school. Explain what would happen to link the interval, the confidence interval increase to 99%. Well, if you make your confidence interval bigger, because you want more confidence, right? Like you want to feel better about, like, okay, you know, you're 95% sure that's between 60 and 69%. If you want to be even more sure, means, you know, you want, of the 100 intervals you would make, or 100 samples you would produce, you want 99 of them to contain the true percentage. So you're probably going to want to make that interval wider. So if we increase the confidence level, then the margin of error would also increase. And let me type this up because it'll be a little easier. The reason why is that we want more of a guarantee that our CI can capture the true percentage of people, percentage of US adults who favor this amendment. There we go. And so you have to make it wider if you want more of a guarantee. So hopefully that makes sense for part A. For part B, how would a 95% confidence interval based on double the sample size compare to the original? So if I double the sample size, so remember we talked about margin of error being Z. That's in the presentation I shared with you guys yesterday. And we discussed Z times sigma root N, where N is the sample size. So it's how many people you actually surveyed. If you increase that, then what's happening is that you're making this fraction smaller. Ultimately, the margin of error gets smaller. So that's how we're going to answer part B, is that the margin of error would decrease. And you can kind of use this math up here and kind of like just take a kind of a numerical approach, if that makes sense, where, okay, root N is the denominator here, N is being the sample size. If I make that a bigger number, like for example, you know, if I have like 1,000 divided by root 100, or say root 25, that's 100. That's 1,000 over 5, right? That's 200. But if I do 1,000 divided by root 100, 1,000 divided by 10, now it's 100. So now I've reduced my margin of error when I've made my sample size bigger, because whenever you increase the denominator of a fraction, it makes overall the number smaller. And another reason why this would make sense, let me type it down below. The reason why is because we can be more precise with our interval when we have more people in our sample. Yeah, because when you have a bigger sample size, the data becomes more reliable also. So for example, if I were trying to predict the outcome of like a football game using some historical data, if I only looked at like maybe the last like maybe 10 games played for a certain team, that may not be enough. Maybe I need to look at the last maybe 100 games they played to get a better feel for how the team might perform. So again, you always want to have big sample sizes if you want more accurate, because the smaller the margin of error, then the better you feel about your estimate. Then like if you're trying to predict like who might win a presidential election, or maybe it looks like we're gonna have another gubernatorial race because Newsom's facing a recall. Yeah, if you want to be a little more confident or accurate, that you probably would want a bigger sample size. Okay, and then lastly for part C, the news article goes on to say theoretical errors do not take account additional errors resulting from the various practical difficulties in taking any survey of public opinion. Lists some of the practical difficulties that may cause errors, which are not included. Remember, the margin error we talked about last time. This is just do. Actually, let me erase that. Just do to sampling errors or mishaps. What may not capture would be, and actually, let me pull up the presentation one more time just to show it to you. Where is it? Here it is. Yeah, it covers only random sampling errors. No other source of variation or bias. So like undercoverage and non-response could be some practical problems. So what are some of the practical difficulties? Any bias that might happen, like maybe it just so happened that you surveyed a bunch of people, even though you did it randomly, a bunch of, asking who they're going to vote in the election, a bunch of people who might be of a certain demographic that would favor Trump or Biden. So bias or undercoverage, if you didn't maybe ask enough people, maybe your sample size is too small, or it could be also people not responding. So people who do respond would be people that would want to say something like, I'll give you a good example. What if we did a survey of to our parents of like, hey, how have you felt we've done with COVID? Our response to COVID-19. Some people who probably don't really feel one way or another, or they think we've done a good job, they may not fill out the survey. Where those people who are really upset will fill out the survey. And then that's, so because there's some people who did not respond, that, may not be really telling us how people really feel, or what kind of job we're doing, because sometimes people only respond when they're pissed off about something. So you have to be, mindful about all that. And that's kind of a whole other topic and branch of statistics, how to actually do a survey properly. And it's tricky. But anyway, we'll keep moving. Okay, so we saw this schematic also last time. Actually, it was right over here. Yeah, we saw that. So the figure shows the result of taking 25 simple random samples. Remember, SRS stands for simple random sample. From a normal, so remember, normal distribution is right here. That's like a bell-shaped curve. And constructing a confidence interval for the population using each sample. Which confidence level, 80, 90, 95, do you think was used here? Okay, so this right here, give me one sec here. Let's count how many I have here. Excuse me. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, good. So I have 25 intervals here. Now, usually we want to be contained within 2 standard deviations. That's typically what we want. And so hold on a sec, let me get a little calculator here. There we go. Yeah, so we see that, let me get a highlighter, actually it's probably better. Let me make that a little thinner. And let me draw this also. So usually you want your intervals to be within 1 standard deviation for it to be considered kind of a valid, or to actually capture the true mean. That's usually what you want. And we see that 4 of these don't quite do that, because the mean here, you have this mark, this marking, this marking, this marking, are more than 1 standard deviation from the true population mean. So whenever you're more than 1 standard deviation away, it's usually considered not a good confidence interval. So let me kind of type that in. Any CI with a sample mean that is more than 1 standard deviation away from the population mean is not considered a good CI. And just so you know, the population mean is given by this alphabet, mu, right, mu, and the sample mean is given by X bar, just so you know. So all these little dots here, or these little like markings on each of these intervals, represents various X bars for all these different components. We made 25. There are 25 CIs here, 25 CIs total. 4 CIs are not good. And why are they not good again? Because, this is 1 standard deviation. That's, mu minus the 1 standard, which is mu plus 1 standard deviation. So these here are more than 1 standard deviation away from the mean, population mean. So, so 21 are good. 21 out of 25 is about 84%. So I would probably say, which confidence level do you think we should probably use? Probably the 80 or 90%, because it's close enough. That's what I'd probably say for that one. So that's how you read it. Again, any confidence interval that's more than 1 standard deviation away from the population mean is not considered good. And again, that should be in the presentation. I believe it was mentioned. It was a little bit earlier. Maybe not. I don't remember. Anyway, we'll keep moving. I thought I had mentioned that, but anyway, but that's usually because they're not good. Okay. Explaining a 95% confidence for the mean body mass index of BMI, which you guys might be familiar with if you're familiar with nutrition or sports medicine, of young American woman is 26.8 plus or minus 0.6. Okay. So what this means is that if I actually surveyed a bunch of young American women and asked asked what their BMI was, or maybe just went to a bunch of doctors and said, okay, of the BMIs you collected from your young female patients, what's their BMI, right? And so I would do a survey, and I'd find what the average BMI is. Great, 26.8 was the average. And then you calculate the confidence interval. Remember, the confidence interval is calculated by doing this. It's X bar, your sample mean, plus or minus Z times sigma root n. Remember, X bar is your sample mean. Z is your Z score. And there's a variety of Z scores that are based on the CI level. And I'm going to show you how you can use your calculator to get your Z score based upon the CI level. Remember, N is your sample size. And sigma is the population standard deviation, okay? So that's how this was constructed. If you surveyed a bunch of women or asked a bunch of doctors, hey, what's the BMI for your patient? Give me all the BMIs, and if you average all those BMIs, that's what you get. And then, of course, if you want to do 95% confidence interval, you can get the margin of error. And of course, you need to know the population standard deviation and how many people you actually surveyed. If I conducted this survey 100 times, then 95 of my 100 intervals that I would be generating would actually contain the true BMI for young females in this country. And remember, 26.8 plus or minus 0.6 is like saying if I take away 0.6 from that, that's 26.2. Or if I add 0.8 to that's 27.4. So I'm basically saying that I'm 95% confident that a woman's BMI is going to be between those two numbers. Okay, and remember, BMI is body mass index. I forgot how that's actually calculated, but that's beyond what we really need to worry about here. Okay, so discuss whether each of the following explanations is correct. Okay, so just be careful about the wording here. So we are confident that 95% of all young women have BMI? No. We are 95% confident that young women will have a BMI in that range. Not that 95% of the women will. Remember, it's not a probability. So CI is not a probability. Very, very important. So the answer is no. For that one. For part B, we are 95% confident the future sample of young women will have a mean BMI. The problem is future. So remember, our sample is for the present, for right now. Who knows what's going to happen a few years from now? Maybe diets will change. Maybe we have a food shortage, or maybe you know, do people start loading more preservatives in the food? I don't know. I mean, you know, I will say I think our society has become more obese because, you know, we you know, have more access to junk food, and we don't live in an agrarian lifestyle where people are more rural and out working. A lot of this, especially in this pandemic, we've been sitting down a lot. So, but anyway, it doesn't predict the future. Just so you know, this is just more about what's happening at the present current moment. So I would say no again for B. That's not correct. Any value from 26.274 is believable as a true mean. Yeah, I would say yes. I mean, it kind of lacks a bit of formality, but yeah, I would say yes. Believable, or I like to use the word plausible. It sounds a little more sophisticated, but yeah. If we take many samples, the population mean BMI will be between 26.2 and 26.4 and about 95%. Okay, so we have to be careful here. It's not, yeah, it's 95% of your intervals will capture the true mean, but the population mean will be between and about 95%. Yeah, oh, actually, if we take many samples, sorry, I think that what they meant to say is that if you increased, you know, D is just like A, just so you know. It's actually treated like a probability. So the answer is no again here. I think what they meant was if you asked a lot of adults, then 95% of adults will have, again, it's not a probability. Okay, and then this one, the mean BMI cannot be 28. Well, no, of course it could be 28. Or greater or less. Remember, we're only 95% confident, so there's 5% of intervals or actually, let me rephrase that. We're 95% confident not 100%. So we could be wrong, right? I mean, you know, again, like when you know people were trying to predict the 2016 presidential election, people were using these confidence intervals, and many of them had Hillary winning, some even in a landslide, and those were wrong. They were way wrong. So yeah, so you know, it's not 100% certain, right? And you never even do 100% confidence interval. You can do 99.9%. Well, then would that make the interval even wider? So then sometimes it becomes, well, what's the whole point of that then? 95% is kind of the sweet spot, just so you know. That's kind of an ideal CI. That's what usually what a lot of statisticians will use. Okay, so now I'm done talking about that. I'm gonna give you guys about 20 minutes to do these multiple choice questions and work out number 21. Again, you have a confidence interval, so you have a sample of 572 employees. So let me kind of just make sure you guys know what's going on here. So N is 572. Your CI is 90%. So just so you know, the Z-score, so the way you can calculate this, actually I do need to kind of explain that to you. So if you see right here, it says second distribute and 3 inverse norms. So what you do is you hit second vars. So second vars, and then you pick option 3. And then when they ask for the area, it's a little tricky. So when asked for the area, they're asking for, well, first of all, if you want a 95% confidence interval, this is what you want. So it means that there's 2.5% here. This is for a confidence interval that's 95%, and 2.5% here. The way the calculator does it, they're asking for the area that's to the left of your far right endpoint of your interval. And they want the entire area, even the left tail. So it's basically the whole normal distribution except the right tail. When they ask for the area, they want the whole distribution minus the right tail. The right tail is 2.5% for a 95% confidence interval, because if you have 95% confidence, you have 2.5 to the left, 2.5 to the right. So you actually have to type in 0.975. So when you actually go to inverse norm in the calculator, so when you actually type this in and ask for area, you actually have to type in 0.975 for 95% CI. I know it's a little confusing, but that's what you would do. So for a 9% confidence interval, going back to the worksheet, for so again, n is 572, we know this. For CI that's 9%, your z-score, you're actually going to do, so again, here's a bell-shaped curve. You want 90% CI, right? So then you have 5% each of those tails. So when you do the area, you're actually going to type in 0.95. So if I do that calculation again, so second vars inverse norm, 0.95, you get 1.645. So 1.645 will be our z-score here. Just so you know. And they do give you the interval from 23 to 26. Okay, so they actually are just asking more to interpret, not to compute, but just wanted to help you with calculating with the z-score. Also, you could, if you want to just do a quick Google search, z-score for confidence interval. And it kind of gives you right here. I mean, quick Google search does it. 99% is this, 99% is that, 95. You could even click on that and it'll even kind of give you a nice little table there. It does tell you like the area, but I think you click on a Z table. It's a little confusing. I think sometimes it's just easier just to kind of go with what you see right when you do the search. So anyway, and then of course you have a bunch of multiple choice questions that follow. So again, we'll do this for about 20 minutes, around 1:15. We'll check the answers, then we'll do a little break, and then we'll do worksheet 2 after that. So let's do a 20-minute breakout session. I'll just put you guys in pairs and just work to help each other out. Call me over if you have questions. I'll put the answer keys up in just the next few minutes so you have them there. And then we'll come back in the main room to go over this, and then we'll do a break after that. Okay, so let's do the breakout sessions. I'll pause, well, I'll just stop the recording, okay.